This is one I've been kicking around for years and I just never made a video on it. Turning off your 3D printer automatically after your print completes. Hello everyone, Chris here, and yes, turning off your printer automatically after a print completes can be really handy in a lot of different situations and can save you a lot of money on your electricity. And I have kicked this around for a long time. What's the best way to get this done? And there's a lot of different ways you can go here. So I really never found one that I liked enough to do a lot of content on it. But let's talk about a couple different ways you can go. Now, one of the first options that you might see if you're looking around is something like this, an IoT relay. These are actually really common in the CNC world, but you could hook this up to get it to turn on and off your 3D printer if you wanted to. In fact, Chuck, over at the CHEP channel, did a Filament Friday episode on it. I'll leave that link in the description below. He did a really good job on this setup, but it takes a few extra steps to figure it out. There's also a couple of really handy plugins for Octoprint if you're an Octoprint user. And that way you can utilize 5 volts to maybe keep your printer on enough to maybe kick it back on if you wanted to. It's a little more advanced setup, but it could be a really nice solution. And then you have things like this. These connect directly to your main board. You can select a pin and then trigger this relay to kick the power on and off. This is the avenue that I decided to go with because I think it's the most interesting and maybe the most fun to set up. Now today we are not going to be trying to turn the printer back on. Again, that would take an additional power source. We're just going to be focused on turning the printer off after the print completes. Now the setup that we're going to do today is pretty simple. Again, we're just going to be focused on shutting the printer down safely with that relay. But this relay setup can do a lot of different things, and there's a lot of different settings in the firmware that you can use that are more advanced than the ones that we're going to check out. And there are multiple types of firmware that can do this, but today we are going to be focused on Marlin. So let's start out by checking out the relay and all the different plugs and options that you have on this module. So let's start here. Let's take a look at the Bigtreetech relay module we're going to use for this build. Now, the information on this module isn't all that great. The pins are in Chinese. You really can't tell what's going on from the information from the GitHub. But there's a little bit more information out there on it. I'll show you that in a moment. But basically, we have the AC side, and then we have the DC side, and a relay. So you have a lug here for AC input, a neutral lug, and then AC output. So these two are going to be hot wires. This connector in the center here, this is the one that you're going to want to use for your PS on pin. We're going to use it for shutdown, but we call it PS on in the firmware. These seem to be power failure pins, so maybe you can signal a bank of capacitors or something like that when the power does trigger. And these over here seem to control the relay, so you can switch it on and off. Now there is something built in here. There's kind of some firmware logic. You can talk to it with some UART pins over here. And you have this jumper right here. These pins offer you some sort of short circuit detection via the firmware. You can cap them if you want to use it. Again, there's not a lot of information on how it works, but I'll play around with it and report back if I find anything interesting. And then these pins over here. Now, once you trip this with firmware, unless you had 5 volts to power this module or your board, you're not going to be able to trip it back on with G-code. So that relay will stay open. So to get back up and going, you can either turn the power off to this module via the AC switch like we're going to do, or you can use these reset pins over here. We just set a switch on there. That should close down the relay so that the power can start flowing again. So there's a lot here in this little module. We're not going to use a lot of it. We're just going to use it to shut down, and then we can manually restart. You can see on the back there's really no badging for any of those pins. There is a lot of warnings, and as I said before, be really careful here. You're going to be exposed to AC all the time when you turn this on. You don't want to use this as a bare board. You need a case. And that brings us to our next point. There's a great build over here on Thingiverse. It's listed as a city in Scotland by Bob Smith, so I'm not sure who the actual creator is, but I'll leave a link. Check it out. He did a great job on this. He tries to give you an explanation of what a lot of these pins do. I'm not sure how accurate this power failure one is, but for the most part, it's going to work for you. The big part of this is he created a really nice case. Now, I did alter mine a bit, and I will leave a link to the remix and this original one, but you're definitely going to want something like this if you do this build. You can't be exposed to this module in any way. And another big advantage to this one is that it's modular. The way we're going to build it, we could plug it into any printer and use this, as long as you had access to that PS-on pin. And he has a spot for that reset switch, so you don't have to get behind it and trip this switch to reset it. With that Bigtreetech module, you also do get some wire for your AC and a couple of prepared JST connectors. I'm going to build my own AC wire loom because we're doing something a little bit trickier, but you do get a handful of parts if you need them. So here's the case he created. I did make a few changes. Again, I put some holes here in the front because we're going to use an IEC connector for this. More on that in a moment. And then on the lid, I just shrunk some of the holes because for the reset switch, I'm going to use one that's quite a bit smaller. But this is actually a pretty good fit. It's nice and tight on here. You could use some glue or something if you wanted to make it permanent, or, remix it, make your own case, put some screws on top if you want. But it's a pretty nice box altogether. The relay sets in here. On these posts, you can use some M3 screws. I'm going to use M3 by 8s. They fit just fine. Now that our relay's secured, let's talk about this IEC 320 C14 adapter. This makes this really handy to use because you have your power switch and you can do your input here and then put your output on another cord. But let me show you how to get all this wired up. You will need some wire and some blade connectors. So for your hot lead, I connect these two terminals with a really short piece of wire and some blade connectors. This gets you over to the switch so you can turn it on and off. All of these connectors over here are the constant ones. And then this lug right here is for your neutral. I'll put a neutral lead there and put it just on the other side of that hot lead. We'll talk about ground here in a second. That's going to go to the printer ground on the PSU. But then from the other side of this switch, to make this module switchable, I'm going to put a blade and a spade connector, the hot lead right here, and the neutral one right there. Then for the output, the one that's going to go to your PSU, I just took a cord that I already had. I put a blade connector on the ground wire. That'll go to our IEC plug. And then spade connectors on neutral and the hot lead. These will go to our relay. And then this side can just go into your printer, of course. But this makes it modular. And before we hook it up, we can just slide it through the lid on our case. That's what the larger hole is meant for. And once our pigtail's through the case, then we can just run it through the top, and our ground is going to go on this IEC plug right here. Now we can go ahead and put the IEC plug, we can mount it to the case. So I've got our IEC plug mounted. I just use some M3 countersunk screws and some M3 lock nuts on the back. That bottom one can be pretty challenging, but you can get your finger in there on it and use a socket to tighten it down. It might be a little tricky, but I have faith in you. But after you have that mounted down solid, now we can start wiring it up. So this side is your input power, and that's where your plug is coming in at. So input into here, your hot wire is going to go to this terminal. We can screw that down. Then your input neutral will go to the center, as well as the one that's on your pigtail, your output. The neutral for that will also go on the center, like that. And then your output hot wire goes on this lug right here. So now you're done with the side for the AC. Now on the DC side, I will show you about these reset pins over here. You can use a button, but the main one we're concerned with is this one in the center. So we're going to use one of the JST style connectors that they gave us from Bigtreetech. We're just going to plug it in on this center one. Be mindful if you're using the wires that came with your module and not making your own. Just be sure you know which wire went to signal and ground. I've noticed some of these are flip-flopped. I'm going to use red for signal and black for ground. That'll be important when we go over to the board side. Now on the board side, we're going to hook this to a PS on pin. And that can be configured to pretty much any digital pin on any board if you set it up in the pins file in the firmware correctly. But I'm going to show you how to do all of that. But for now, we definitely want to put our lid on, close up shop, so that we can't get to any of this AC juice while we're testing. Be as safe as possible here. I'm not going to plug it into the wall yet, but this is the wall side. It's going to go back here. We'll turn that on. And then this side is going to go to your printer. And we'll attach this to our PS on pin on the printer board. Now let's talk about Mainboards here for a second. You have a couple ways you can go here. This is an SKR13 board. It doesn't have any PS on pins labeled, but you can use pins that you're not utilizing for other things. A lot of times you'll see the PS on pin or the power detect be in the space for Z max. So these pins right here. And you're going to see 5 volt ground and signal. For this module, we're only interested in ground and signal. So you can either break your JST connector up into a 3 and just use 2 of the wires. You can also pull these shrouds off. They hold pretty well in the pin even without the clip. But you might have to get just a little bit creative if you have one with 3 pins. With an SKR14 board like this one, you're pretty much in the same boat. You don't have PS on pins. They label those same pins over here as power detect. They intend for you to use this with something like a capacitor module, so you can detect when the power goes out. But again, you can use these the same way. Switch over to a 3-pin, or try to utilize ground and signal here. Same thing as 1.3 and 1.4 on the Mini 1.2. I don't have a 2.0 to show you, but they have power detect pins, and there's 3, no PS on pins. Something like the SKR2, you have dedicated PS on pins, and those are going to be configured inside your pins file in Marlin. So just keep that in mind when you have your board. You can use any digital pin you want, but some have dedicated PS on pins. For this video today, we are going to use my poor SKR13 board. It has been through a lot, to say the least. You can see I don't really have any surrounds on any of these pins anymore. I've tried so many different configurations. But the pins we're concerned with, just like I told you before, are the Z Max pins. I don't use those for anything, so we're going to use them as PS on pins. And you can see we have signal, ground, and VCC. We don't need any voltage for this, and I don't have a surround on this, so I can just slide the 2-pin connector on. That's probably not the configuration you want to use. If you're going to use something like this, I suggest you build a 3-connector JST and just don't use this pin. But for our detect module, our red wire is going to go to signal, and our black is going to go to ground. So it would go on just like that. And then we can tell the firmware what pins we're using to make this power off. No matter what board you're using for this module, you're going to signal to ground. That's how the PS on pins on most of the boards that I see are configured. So there's the hardware side of things, and the PS on pins are getting more common on main boards now. You can do this with pretty much any main board, again with a lot of different firmwares, but Marlin, you pretty much just have to have an open digital pin, and then you can adjust the pins file to go along with that. And that's what we're going to tackle now. Let's jump into VS Code and check out the Marlin changes you need to make. So for PSU control in the firmware, there's actually quite a few things you can do. We're just doing the basic settings right now. We just want to turn the printer off. So one line is really all we need. PSU control, we're going to take the comment off of that. PSU name, you really don't need to use this. Maybe you have multiple power supplies. This might be helpful in a couple scenarios, but we're not going to use it. The pins on this board, they are going to stay high while the pins are active. And then they'll go low when you do the signal. So by default, the PSU state is set to low. We need to set ours to high. They actually set somewhere around a volt and then turn to off when we run that M81 command. PSU default off, it will stay off until it sees an M80. That would require a 5-volt source of some type. You'd have to be able to keep your board on all the time. Maybe you could do that with Octoprint or something as well, but that's a different config. And then PSU power up delay, you can set that parameter here. It's pretty self-explanatory. We don't need that. And then there's also auto power control. This is a lot more complicated of a setup, but the features are here if you wanted to use them. This would be a scenario whether you had the board powered up by 5 volt, you were using a different PSU maybe to control different options, then you could turn a PSU on or off based on certain scenarios. Like, if a fan needed power, then you could turn your PSU on. Or if your temperature of your hot end was a certain degree, then you could kick it on. This just gives you a lot more options that you could do with a more complicated setup. Today, we're just interested in getting the printer shut off. So we're just going to use pretty much the defaults for PSU control. Now, the only trick is, what pin do you use to get this to happen? What are you going to use as your PS on pin? In your files, if you go to Source underneath Marlin, you're going to have pins. And this is where you're going to define what pins you use for PS on. Now, mine is the 1.3 board. You can pull it open right here, but most all of the features for these boards have a common file. These are just the features specific to the 1.3, and you can see at the bottom of that file there's an include for SKR common. And that's where I'm going to make my adjustment. In here, there is no listing for PS on, but you can define it just as whatever pin you would like to use. So pick a spot. I like to put it underneath the step pins if there are some, but I'm just going to do pound define. We're going to do PS underscore on underscore pin. And then select your pin number. You can line it up over here on the side if you want to keep it clean. On an SKR13, that pin that I showed you, that Z max, that is P1 underscore 24. You're probably going to be able to get these pin numbers off the back of most boards. If not, most boards will have a GitHub page that lists all the pins. Here's the GitHub for the 1.3 board. Your pins file is going to be right here. And here you can get all the numbers. So Z max over here, that signal pin, 1.24. So that's the pin we're going to use. And with this configuration, that just tells us that the M80 and M81 commands for on and off utilize pin 124. So that's how you would add one if you needed to. And you shouldn't be worried about using that for multiple reasons, like having it as 124 for X max and 124 for PS on. It will complain when you compile it if that's a problem, but most of the time, as long as you're not using it, trying to use it for two different things, you should be okay. If we take a look at something like the pins file for the SKR2 board, you can see they already have PS on pins defined to that isolated pin that I showed you before. It's already set up. So just use those pins and you should be good to go. This is going to be very similar for a mini board, a 1.4, a lot of the different boards that you want to do this with, even the 8-bit boards. You can add it, define it as a PS on pin. Now that we have everything configured in the firmware, we've got our relay set up. I have already flashed the board on this. I don't have anything else hooked up to the board. This is just for this test, so there's going to be some errors, but this is going to prove that that relay works. So the first thing I'm going to do is plug the printer into the relay, so the output side, and then we'll turn the PSU on. Then with the switch off on our relay box, I'll plug that into wall power. And then we can turn our relay box on. And the printer will start up. You can see I have some TMC connection errors because there's no drivers on that board, but you'll get the gist. Now when the print's done, we want to run an M81 command to turn the machine off. And just as a test, I'm hooked up USB to Pronterface so we can manually run our M81 command. We'll just do M81, enter. You're going to hear the relay click. You can see 3D printer off. And the printer is off. Now, if you want to turn the printer back on, if you had 5 volt powering your board, you could send it an M80, and the firmware would kick it back on. But we have our relay tripped over here. So you would have to use that M80 to reset the relay as well. You have a couple of options. You can just cycle the power on this box for the relay, turn it off, you can hear that relay clip, and then turn it back on, and your printer will come right back up. You can also use those reset pins with a switch, and let me show you how to set that up. So again, you can reset this whole relay just by shutting the power off. We have a module back here to do that, so it's relatively easy. We can just grab the switch, but it is just a little bit more convenient to use a momentary switch to do the reset pins. So I just grabbed one of these on Amazon. I'll leave a link, but it's normally open. It's momentary. You hit it, it closes it. I just soldered some wires on the back, and I put a DuPont connector on the end, and you can plug this directly in to your reset pins. That's these two right in here. Doesn't matter which one goes on which. Shorting them out with that momentary switch makes the relay reset and your printer will come back on. Easy enough. The switch could make things a lot easier in this whole configuration, depending on how you set it up. So let's test that out real quick. We're powered up, printer's on. When you turn that PSU control on, you'll actually have a menu option to power off. It's right in the main menu here. Switch power to off, and that'll kill the power. The relay trips, printer goes off. But now with our reset switch, it's a lot easier to turn the printer back on. You can see it back here. We'll just hit it once. Power comes back on. So this might be something that makes this just a little bit easier for you to use. So consider that option. So we've got the hardware set up, we've configured the firmware, we've tested it, everything's working as expected. But now we need to set up a scenario that will actually shut your printer down safely. And I like to do that in the NG code in the slicer. With this setup, you could really easily move it to a different printer if you wanted to, and then all you would have to do is adjust your NG code accordingly. Now you want to do this because you don't want to just shut off a printer while it's up to temp. You want your hot-end fan running as long as possible until it gets down to a safe zone. Or that filament's going to cook inside there, maybe up higher in the barrel, and cause a really serious jam. And you don't want that. So now let's jump into the slicer and get things configured so we can do this safely. I am going to use this relay inside G-code. I'm going to use it in my NG code to turn the printer off. This is the simplest way, in my opinion, to do it, and then you can take this whole relay module and put it on a different printer if you want. You just have to move your NG code to that profile. So in my profile, I'll just go through and describe all of these. When we're done with the print, I'm going to turn the part fan all the way up. So it helps us cool our hot end and our bed down. Because you don't want to leave the hot end on or even up to temp if you're going to turn your printer off. So first step, we'll cool it down. So part fan on. Then we're going to turn off the heaters, M104 to turn off the hot end, M140 to turn off the bed. Then we're going to do an M109 R50. This is going to wait for the hot end temperature to get down to 50 before it continues. Then I'm going to move the bed out to 200 so it's easier for me to remove the part on a Cartesian Prusa style. This just makes it a little easier to get to. And then I'm going to do an M400. This will wait for everything to complete before it moves on to the rest of the NG code script. At that point, I'm going to turn the motors off. I'm going to turn my part fan off with an M107, and then my M81 to shut down the printer. So let's just kick off a really simple print, and we can watch this in action. So our print has started. I'm not even loading filament for this one. It's just a test. It's only a couple of layers, and then it will start the power down sequence that we have in the NG code. So our shutdown NG code has started. You can see it set it to 50. It turned the bed off. The fan is full blast. But there's one thing I forgot. I should have told it to go home when it was done. That's easy enough to correct. But let's go ahead and watch it do this cycle. We've cooled down. It put the bed out to 200. Stop the fan. Stop the motors. Hear the relay click. The printer powers off. Now let's fix it up just a little bit to get it away from the part. I'm going to switch to relative mode just for a moment with G91 so that I can tell Z to move. And then I'm going to tell Z with a G1, I'm going to have Z move up 5 millimeters to get it away from the part. Feed rate, 5,000 is fine. It will never go that fast, but we'll just throw that in there. Then I'm going to come out of relative mode and go back to absolute with G90. so that the commands below this G1 command will work as expected. Then I'm going to have it do G28X. That'll just get the X back to the end stop. We can deal with Y after the print's done with this command below. That should work out a little bit better for us. Let's go ahead and test it. Now this time when the print's done, we raised 5 and we went X home. That's much better. The fan's on full blast so that it'll start cooling down the hot end, and then we'll wait for it to get down to 50. You can see it has 50 on the screen right now. We made it down to 50. The bed's going to slide out to 200. Fan's going to turn off. Motors turn off. Then you're going to hear the relay trip. And then the printer will go off. Now we've safely shut down our printer. So there it is. We were able to get our relay and firmware set up and shut our printer down safely after a print completes. And as I said before, there's a lot more of advanced things that you can do inside the firmware around this scenario, shutting down the power on your 3D printer, including multiple power supplies if that's the route you wanted to go. Also with this relay, there's a few more options. You could set up a really robust scenario if you wanted to. Maybe add in a UPS module with some capacitors so you'd have a more rigid auto power down if you hit power detect. There's a lot of interesting things here. I might try a few of them in the future. That is it for today. Hope you liked this video, and I'll see you really soon in the next one.